Right, good morning, everybody. So today we are going to discuss about still in segmentation, chapter 2, segmentation. So last week we have discussed about the key things about segmentation, where you need to have some form of similarities and also connectivity, so that you could connect things together to form an object. And after that, we have also discussed the issues, okay, after segmentations, where you tend to have very small object like this one, many small objects and many small holes. So today we are going to discuss about morphological operation, which is the operation used to simplify a segmented image, okay, by removing small object, joining the small holes so that it become one bigger holes, okay, so that you have only very few objects left, all right, like in this case. So that is our discussion today, morphological operation, which basically you can click under segmentation part 3, and then you should get this file. All right. So if you look at here, what we want to do here is we want to simplify segmented image, so that we can easily search for our object of interest. So what we do is we try to smooth out object outlines, fill up small holes, removing small object, and then so basically we use two operations, dilation and erosion. Right? So dilation, basically you allow an object to expand. So from here you could fill in small holes and connect disjoint objects. Erosion, on the other hand, what we do is we try to etch away or erode, okay? So we can eliminate small object and remove some of the boundaries, make it smooth. So we can actually customize this operation by means of structuring element. So you see that we'll always have to define structuring element so that we could perform according to what we want. Okay, so we go into the actual operation. All right. So the dilation is actually performed by laying structuring element. Again, this is a sliding window operation, sliding it across, like similar to convolution. The difference is in this operation. So what we do is something like this. First step, as you slide through the image, so if coincides with 0, meaning that if the middle pixels is 0, then there is no change. So you proceed to the next pixel. And when the origin or the middle of the window coincides with 1, and you perform all logic on all the pixels within the structuring element. So maybe it's best to be explained by using an example like this. So suppose I have an image like this. So how do I perform? So I copied it into a buffer. Okay, so I have a sliding window operation. So starting with this window. So what is the middle pixels here? 0 or 1? Everybody? Anyone answer me? 0.
0.
So, yeah, so if it is 0, what should we do?
No change.
Yes, exactly. When it comes to 0, there's no change. So move on to the next pixel. So we move on to the next pixel. So we move 1 pixel to the right. Anything happen here? Again, what is the center?
No. No, still 0.
Zeros. No 0. Okay, so 0 so means no change. Move to next pixel. Exactly. Okay, so what about this one? Again, the same. So you're going to repeat this all the way until here. No change. What about, okay, now we come back to the leftmost and we will go 1 pixel down. Anything happen here? So the middle is 0. No. So you can see that the middle is all zeros for this particular row. So there's no change all the way until this location. So now we move to 1 pixels down, leftmost. Anything happen here? The middle is 0. So no, nothing happens. Here we need to do something, right? So the middle pixel is 1. So what happens when it is 1? Coincides with a 1, you perform OR logic with the structuring element. So this is the structuring element. White color represent 1, black color represent 0. So whatever that you OR with 1, what do you get? Anything OR with 1, you get 1. Correct? Are you following?
Yes, sir.
Yeah. Okay, so when you OR, you perform OR logic now with the structuring element. This is a structuring element. Okay, so all the white color here, 1. So what happens when you OR with 1? You get
1.
Yes, you get 1. So I OR with this structuring element. So all this, so this is the center. So the surrounding 4 pixels here are 1. So this is how the structuring element look like. So when you overlay here, so what happens when you OR with this? So the 1 when you OR with 1 remains 1, right? But the 0 when you OR with 1, what happened? It becomes
1.
1. Exactly. So I put here, but I put slightly different color, big gray, to indicate that it used to be 0, but now it has been turned to 1 after you OR with this structuring element. Do you observe that practically you are expanding the object? It used to be only 2, 1 here, but now you have additional ones surrounding this. And this actually, the pattern follows the pattern of your structuring element. So that is the effect that we want. When you do dilation, practically you want to expand the object, like what is explained in the notes here. All right, expand the object. And the use of structuring element is actually for you to customize, or in other words, for you to determine how you want the expansion, how you want it to expand according to what pattern. And this is actually very important later on for you to preserve the shape of the original object. Okay, let's move on. So we are done with this sub image, and then we're going to move 1 pixels to the right. So what happened here?
Change.
Yeah, so you can see that this 2 already 1. So and the 2 0 here, when you OR with the 1, then you get 1, isn't it?
Yes, sir.
So now we are done with this. So are you following? Should we move to next?
Yes, sir.
Yes, sir.
So now we are here. What happened?
Change.
Yes, change this 1 to 1. Yes. And then next we move to here. What happened? So these pixels become 1, right?
1.
Okay, done.
1 next.
So this one also become 1. Correct? And now we come move here. So now the 2 0 now become 1.
1.
Okay. And let's goes here. So this 2 pixels will turn to 1. Okay, done. Okay, what happened when you come here? Which is basically this location. Should you do anything?
No.
Yes, yes. That's
No.
why I put this gray one here. It shows that previously it is 0. Okay, it was 0 previously. So for location like this, you don't do anything. Okay. Basically, you are overlaying here this location where the middle was 0, although it has been turned 1, but that's not counted. We will only perform all logic when we coincide with the original location 1. But here now original location 0, right? So we're not going to expand anything. Are you following?
Okay,
If not,
sir.
Yes, sir.
if not, you're gonna keep expanding until you fill up the whole image with 1. That's not our intention. Okay, we will only expand when we coincide with a location where it was originally 1, not those which has just been turned into 1. Are you okay?
I'm okay.
Yes,
Okay,
sir.
sir.
So same goes here, nothing will happen. Okay, so now we come here. Anything happen? No. Here, anything happen?
Yes.
Yes, the
Yes.
middle is 1. So what should we do? Follow structuring. So all the location here should become 1. Okay, so this is 1. All right. So, and then you move on. So again, this one already been set to 1. Okay, the middle 1. So all these 4 should be 1. Then after that, nothing else happened. So if you go through this, you'll find that all the side pixels, each pixels will be filled up, will be turned to 1. This is the effect of expanding the object. And here, all this so that is the final outcome after you perform dilation. Everyone, are you with me? Do you have any questions?
No, sir.
Yes, sir.
Okay, so you see the effect of this is when you perform dilation, you will actually fill up holes like this. And then the disjoint also, you will fill up the gaps. And also you got something which not really your intention. Actually, you increase the size, you expanded the object. We'll see how to deal with this. Actually, we do not want to expand the size of object. What we want is just to fill up gaps and holes. Okay, so this issue can be addressed by doing erosion. All right, so if no questions, then we will go with erosion. Okay, erosion is a little bit tricky, all right, but okay. So erosion similar dilation again is running sliding window operations, but now we try to turn 0 to 1. Okay, just now we turn 0 to 1, now we turn 1 to 0. Okay, so if original structuring coincide with 0, no change like the previous. But when it comes to 1, this one is a bit, I think, maybe not so intuitive. Any of the 1 extend beyond object, then change 1 to 0. So, okay, put it simple. If you find that a middle pixel 1 is not surrounded by 1s according to the structuring element, like in this case here, actually their purpose is to probe for big object. So how do you define big object? Is by defining the pattern of the surrounding 1 like this. So the middle, this is only consider, you will only consider it as the main object when, okay, the middle 1 is surrounded by at least 4 1 according to this pattern. If any of this is not 1, that means it does not qualify itself as a big object, and therefore it should be considered a small object and should be removed. Because the objective of erosion is to remove small object. So that is why if it is extend, okay, when they say extend means if the object is not fully surrounded by 4, 1 like this, then it should be turned to 0 or practically remove it. Okay, let's try to do this. Okay, say this is my structuring element. Okay, so to do erosion, so we start with the leftmost, top leftmost. All right. So anything happen here?
No.
No,
sir.
because the center is 0, so nothing happened. Yeah.
0.
So same goes with this, same goes with this, and all the way here. And then we move down. And same goes for this one, nothing, nothing. This one also nothing, nothing. Okay, so here, nothing, only here. Start to have something. We need to change. So what should we do with the middle one here, erosion? Should we turn to 0? So is it surrounded by 4, 1 according to the structuring element?
No.
No. Yeah, right. Okay, the 2 pixels here are not 1. Therefore, this means the structuring element extend beyond the object. So what should we do with this?
0.
Yes, exactly. We change the 1 to 0. So again, I'm going to use this. Turn to 0. But I changed the color a little bit. Okay, turn to 0. So what about here?
No.
Yeah, the 2 pixels here, this one used to be 1. So the 2 pixels here are 0. So meaning that it is not fully surrounded. So this one should become 0 as well.
0.
What about this?
Same.
Same. Okay, what about this? Same, yeah. So you'll notice that all this actually, because the pixels on top, at least 1, okay, it's not 1. So you need the top pixels to be 1. So therefore, all this will be turned to 0. Okay, what happened when we come here? Nothing happened. When we come here, okay, you can see that the 2 pixels here are not 1. So therefore, this one also 0. This one too, because this one is not, okay, it has to be 1. So this one. Okay, what about this? This location.
No change.
No change because it is fully surrounded by 1. Are you following?
Yes, sir.
Yeah, okay, so this one remains. This one, see, this is 0. So we have to turn to 0. This one too. This one too. This one too. What about this? Yeah, this location.
No change.
No change because it is surrounded by 4, 1 according to the structuring element. Therefore, no change. This one, change. This one, change. Change, change. This one, also because the side.
Change.
Okay. So this one, we are here. So this one fully surrounded by 1, right? So therefore,
Yes.
remain. This one, change, 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 change. Again, this one is fully surrounded by 1. Okay, fully surrounded by 1. So here, okay, this one used to be 1. Okay, but I set to 0. So we refer to the original image. So fully surrounded by 1. Therefore, this one remain. This one change. So you will observe that all those pixels in the middle, but not this, the side pixels all will become 0. So you can see that after erosion, okay, you are practically reducing the size of image and left only the, call it the bones. See, this one should be 0, sorry. See, after erosion, you left only the bone. All the flesh all has been removed. Are you following?
Yes,
So
sir.
you have the dilation and erosion complementing each other. One, you expand and fill up the holes and gaps. Another one is you try to erode, hopefully that you could remove small objects. All right. So you have to use them together because they're complementing each other. So you combine them into either opening. So opening is erosion followed by dilation. So you see, when you do erosion, you remove small object and reduce the size. So we need to compensate those that has been removed. So we do dilation to compensate that. And vice versa, you can do closing, where you do dilation and then you do erosion. Because dilation helps you to fill up the holes, but at the same time, it increases the size. So you will do erosion to compensate this. So we will erode this outer layer and we get our original object with the hole and gap closed. Okay, so this is how it looks like, opening. Suppose you have image like this where you have all the small objects beside. So we use this structuring element where it has to be fully surrounded by one. So when you do opening, what happens is all these except the middle pixels will be turned to 0. So you can see that what happened is you have removed the small objects by doing erosion, but at the same time, you also reduce the size of the object. All right. So what happened is after you do the erosion, you perform dilation. So now you dilate based on this image. Okay. So when I dilate based on the middle pixels, so I get back, I expand following the structuring element. So I get back my main object with all this noise or the small object removed. And closing, I want to close these holes, but when I perform dilation using this structuring element, I close the holes, but I got the size increased. So to address this issue, I perform erosion. So when I perform erosion, I will practically remove all the boundary pixels, the green color. So left only the white and the green, which actually indicates the holes which has been closed. Are you following? So opening helps us to remove small objects. So how do we do that? We perform erosion followed by dilation. Closing helps us to close holes. How do we do that? We perform dilation followed by erosion. Okay, any questions so far?
No, sir.
No, sir.
Okay, if not, I'll go to the sample questions. Morphological operation actually comes out every semester in your final and your test as well. Okay, so this one, page 18. Okay, question 1. What is the objective of morphological operation? To simplify by closing small holes and removing small objects. And how do you determine the shape of structuring element? Okay, since we say the structuring elements is to help us to customize so that we could preserve the shape of the main object. So we want the structuring element to have the same shape as the main object. Now looking at this again, do you see that now the final object actually follow the shapes of this?
Yes, sir.
Yes, sir.
When you do erosion with this, so this becomes the template. So anything which goes beyond this, the noise will be eroded. And same goes here when we try to do a dilation. So when we dilate, it will expand according to this shape, and eventually you get a square exactly like your. So this is like the template that how you want to expand or erode the object. And how do you decide this? So you decide according to the shape of the main object. So if you want it to, eventually you want to have a round object, then this one should be a round shape, and so on. Okay, so the question usually will gives you an image, a segmented image. 1 means the object, 0 non-object, and then you have to decide the suitable operation. So in this case, what is a suitable operation? So most students will talk about dilation or erosion. Actually, that is not the real answer. The closer answer will be either closing or opening. Yes, either closing or opening, because for this you don't use them alone, dilation, erosion, because they will either reduce or increase the size. So you have to use them in pair so that they complement each other. So in this case, closing or opening. So for those with small objects, you do opening. For those with holes, you do closing. So in this case, do you have hole or small object?
No holes.
No holes, but we have, what are these?
Small object.
Yeah, we have small objects. So with small object, what should we do?
Opening.
Opening.
Yeah, exactly. We should do opening. They are small objects, so we should perform opening. So to do opening, okay, so what's the shape of the main object? It's a full square or it's a kind of like cross?
Some kind of cross.
Yeah, some kind of cross. So therefore we use this as opposed to a full square like this. All right, so because this is a cross, so we use a cross like structuring element. And for opening, what should we do first? Opening, we do the erosion or dilation?
We need to do dilation.
No, we do erosion first. Ni
Oh,
erosion
okay.
kan, you nak buang kan, you need to remove small objects, so you erode them.
Okay.
Right, so you erode them. All right, in the process of eroding small objects, you will reduce the size of the main object, but don't worry, you can always restore that by using dilation later. So we'll perform erosion. All right, so so you can see that all these pixels, which used to be 1, because they are not surrounded by 4, 1, right? So all this one, they are not surrounded by 4, 1, so all this will become 0, except those in the middle. See the middle pixels, all the middle pixels here, the 9 here, they are surrounded by 4, 1, according to the structuring element. So therefore, they get to remain. The rest all become 0, including the small objects. Are you following?
Yes, sir.
Anyone having any question? Okay, and then we are going to perform dilation using these results. So we dilate all the 1 here according to the structuring element. So you can see that all this become 1. All the boundaries expanded. So this is the final results. So first you do erosion according to the original image, and then you perform dilation from the result after erosion. Okay, so this is where students tend to confuse. So they perform dilation, erosion based on figure 2, which is not the case. In this case, to do opening, you will do erosion based on the original image, and you get the result here. Okay, so this is result after erosion, where you have removed the small objects, and at the same time you have eroded the boundaries. And this is why you need to do dilation to compensate, so that you could restore this layer of the eroded boundaries. So you will perform dilation based on the results here. All right. So then you'll see that practically when you dilate, so all the boundary pixels will be restored. Any question?
Yes, sir.
Okay, we look at second example. So you are given figure 3. So this is the result of segmentation on figure 2. All right. So the objective pixel label as 1. Okay. So how many objects do you observe visually in 2? How many objects here?
4.
So visually you
One.
you have only one object. But if you do a labeling algorithm, so you label how many objects here? 1, 2,
Two.
3, 4. So all those one, okay, connected, consider one object, connected. But this one not connected to any, so this is separate object. So 1, 2, 3, 4.
Mm.
All right. So ideally, the number of objects detected by computer should be the same as those detected visually. So do you think morphological can help to get ideal results? So we want it instead of 4, we should get only 1. So what should we do? We should do morphological operation. Why? Because
Same as observed.
yes, because morphological operation is useful. It's designed to remove small object and close small holes. So if you are able to remove all the small objects, then eventually you will have only one main object. Are you okay?
Yes, sir.
So if you were to perform morphological operation, what operation would you choose in this case? Opening or closing? Any other
Opening.
small object, and so you perform open.